Hello, friends. We are back of episode 226 of the Our Weekly Highlights podcast. This is the weekly podcast where we talk about the excellent highlights and additional resources that have been shared in this week's issue of Our Weekly, which you can find at ourweekly.org. My name is Eric Nance, and I'm delighted you join us wherever you are around the world. And usually, this is the spot where I introduce my awesome co host, Mike Thomas. Unfortunately, he had an event occur today, so he wasn't able to make it. So I'm going to fly solo on this. And not only flying solo, this will be the first episode in a very long time that we totally revamp how I personally record the episode. I am probably going to move away from the platform that I've been using for a number of years now because they have been bought by another company and they seem to be shifting priorities into the actual recording of live audio. They seem to be focusing more on the editing of it. Fair play. But I want to maybe try a different approach that actually resembles what I've done in the past with another endeavor. So I am actually recording this episode directly in OBS, which was the same setup that I used for the Shiny Dev series, if you recall that. So the audio hopefully doesn't sound that much different. If it does, I will work on that. But this will be a good test run to see what it will look like when Mike joins me again, hopefully next week when we can try this again. In any event, we're here to talk about Our Weekly, of course, not about audio engineering. And the curator for this week's issue was John Calder. And as always, he had tremendous help from our fellow Our Weekly team members and contributors like all of you around the world with your pull requests and other wonderful suggestions. And it's always great, especially as you might say, a veteran of data science and especially using R, since not quite the beginning, but relatively close to it. In fact, I venture to say many of you in the audience may have been born after R was actually released. I would not be surprised. And you may have heard about the history of R either for myself or other community, conferences or other, even podcasts even. But R did not start just with R. It actually has quite a nice lineage. And that is the subject of our first highlight, which celebrates a major milestone in what ended up becoming one of the most influential languages in programming data science and statistics. I'm speaking about a blog post from the official R blog by Martin Plummer celebrating the milestone of the S language now turning 50 years old this month. That is amazing. And so you may be wondering if you're either new to R or maybe just haven't been around as long, what does S have to do with all this? Well, let me tell you what it has to do with all of this. The S language was originally developed by John Chambers and Rick Becker at the very important and influential Bell's Labs, which has been a very, very important institution in the world of computing. I could go on and on about some of the other things that have come from Bell Labs, most notably the Unix language had a big, big help from Bell Labs, but in particular with respect to the S language, it was back in 1976 that John Chambers and Rob Becker started a new project that they weren't quite sure what it was going to turn into, but it started as an interactive way to invoke statistical algorithms that were actually Fortran subroutines, but to have a nice general interface to calling these subroutines and with, structure to the objects going in, like data frames, other objects like scalars and whatnot. And that started taking off, and they later named it S after a few months. And after S, things got pretty interesting. It started to have some books written about S by John Chambers, especially. They call it the Brown Book in 1984. And then when you look in the show notes of this episode, we'll link directly to the the commemorative poster that has been, celebrating the 50 years of S, and you get a snapshot of what these books look like. The first one from 1984 is affectionately called the Brown Book, that John Chambers and Rick Becker co-authored, called S, an interactive environment for data analysis and statistics. Much of what you see in base R came from S. S itself had some interesting evolutions. In fact, some of you may know of a derivative of S that was called S plus. That was actually done by the company Insightful, I believe. And later that kind of petered out. Why did it peter out? Well, after S plus started becoming like a commercial offering of S, well, then you go to the 1990s, 1993 to be exact. That's when a certain set of professors at University of Auckland, Ross Ahaka and Robert Gentleman, decided to take what they were inspired by the S language and kind of extend it a little bit and bring it back to the open source roots, i.e. the R language. So if not for S, we probably would not have R. And if we didn't have R, I would be a really sad data scientist or statistician. It has been so fun to use this in my daily work, hence why I started the R podcast however many years ago. I am so passionate about what it brings to us in the world of computing in general. Yeah, data science, of course, is a key focus, but R, much like Jared Lander often says in his New York R meetups, R can be used for practically anything. I venture to agree. But with that, I do recognize the place in history that the predecessor for R, the S language, has in this journey. So I invite you to check out that poster. It's got a great visual of even what became like a on paper sketch of the algorithm interface that ended up becoming, the mainstay of S as well, and just seeing how John and Rick were thinking about the inputs and the outputs accordingly. Absolutely fascinating stuff. I would love to have a time machine just to be a fly on the wall of how John and Rick were coming up with S, some of the discussions that I'm sure they had. I could watch that for hours upon hours if that had ever been recorded. But at least we have the milestone to celebrate. And I hope that we'll have future milestones for the R language itself. I don't think it'll go away anytime soon. And I'm always here for seeing the impact it will have on our world going forward. Rounding out our highlights today, we're going to look at definitely a modern use of R and another framework in the realm of data engineering, or you might say pipeline generation with data engineering. And in particular, this blog post comes to us from a fellow R Wiki curator, one of the OGs, I would say, Jonathan Carroll, who, as you know from previous episodes, loves to get into a lot of the technical algorithms and the very many adventures in the world of computing and data science. And in this one, he has taken some time to compare two definitely different frameworks, but yet used in a similar context, and seeing how that might play out for you as a practical data scientist looking to maybe choose one of these frameworks depending on your analytical project. So John prefaces by saying he's been getting into a lot of the data engineering side of work. And yes, like me, he's using R extensively throughout this. And just as I alluded to in the first highlight, I see a problem. I often think there's a way to handle it in R. Sometimes maybe I could have done it better in another language. So it's always good to kind of see what else is out there. So workflows and data engineering, you can think of this as you may be getting your raw data from a service or a database. You got to do some processing, maybe some munging, and then you're building maybe a visualization or analysis report. Maybe you're running on an automated basis, and you know that processing is of the essence. You don't want to redo work unless you absolutely have to. This can be hugely important when you're dealing with, cloud-based resources or on-prem resources that are shared, such as maybe an HPC cluster or something. And you want to be a good steward and not run many additional processes or use of CPU cycles unless you have to. So John took this as an opportunity to think about how you might approach a data engineering workflow problem with a couple of different frameworks. One of them you'll probably be very familiar with if you listen to this show, and another one is new to me. We'll start with the newer one. The tool is called DBT, and it seems to stand for Data Build Tool. And this is actually a Python module, the DBT core module to be exact. And it is from the organization DBT, who look like they offer a cloud kind of offering on top of this, but in an open core like fashion. The actual Python library that invoke the workflow in DBT is most definitely open source. There are some interesting examples that he references in the post, such as walking through this, such as a recent data science lab recording from Libby Heerman and others. And as far as what DBT does under the hood, it very much treats a lot of the data processing as SQL-like problems, and that you can basically run even analysis routines into kind of SQL-like processing. Yes, SQL is very, very important if you're in any kind of data engineering of such, but it takes a kind of functional approach to the SQL queries that it develops as part of its pipeline generation. And then we get to the R side of things, and you probably won't be surprised of what John found on this, because it is a very popular way to do it. That is the targets package. Targets is, of course, the package authored by Will Landau, part of the R OpenSci umbrella. It's basically the virtues of the make utility in the confines of R with a whole bunch on top of it. It is very much for managing your workflow. It could be data processing, could be statistical analysis, heck, clinical simulation. I might know a thing or two about that, and certainly Will does as well. You can use it for almost anything. There will be some things where maybe targets isn't the best for, which we might touch on at the end of this summary here. But with the rest, the one thing to keep note, it is all in R. It is not trying to be opinionated on how you do your analysis. If you can write an R function, you are already well on your way to writing a targets pipeline. So with this, let's talk about how John compared the two. He actually took a fun case of analyzing some of his current finances, his spending at different maybe classification of, types of expenses or where he spent those expenses and whatnot. So he talks in this blog post, this is really innovative. When we get to the comparing workflow section, you can toggle between the DBT workflow and the targets workflow right in the same post with the nice little tab set functionality that Quartal offers you in this case. I believe he wrote it in Quartal, but either way, he's got a nice tabbed interface here. So one thing to note for the DBT workflow is he is leveraging DuckDB as the database engine. DuckDB has a lot of great momentum around it. I'm a huge fan of it, but you can plug it in very easily to the DBT workflow. And you organize the workflow in different subdirectories that kind of, you might say, look at the different stages of a data engineering, analysis pipeline. So the first one being a sources YAML file. So if you write YAML, like I do a lot with either Quartal headers, R Markdown headers, or Golem configs, YAML is a very powerful framework for all this. So luckily in this data that he's working with is a bunch of CSV files he's exported. So DuckDB does, of course, have a built-in method to read CSVs. So you can do this within the database. You don't have to shell out the Python for this. You can literally just take advantage of what DuckDB has to offer. He reads these CSVs in the raw directory that he set up. And then as far as there's a sources YAML file that tells it how to read it. To actually read it, there is another SQL file called stg_bank.sql. And this is where you are writing what looks like SQL code, but you kind of do this interesting idea of like these functions such as filtered as or clean as. And these are kind of like the quote unquote analytical side of the pipeline. But within this, you can put, say, a select statement, a where statement. If you know SQL, you'll know exactly what those are all about. You might do some processing in there as well in your selecting maybe regexes or whatnot. And you could have any number of these kind of processing SQL scripts. As long as you reference them in the YAML file that you outline for that step, you'll be just fine. And in fact, I think you can have different YAMLs for the different parts of the process. But it goes from not just ingesting the data, it's also maybe joining multiple tables together or munging it of sorts. And that's where there's another step in this intermediate section where he does transactions, so to speak. And then to generate the summaries and outputs, that's yet another subdirectory in this. There's like a models marts subdirectory, yet more SQL. Then in this case, might just do an aggregation, such as like average spending by the different categories. You could do all sorts of things there. DBT also comes with some nice ways you can add testing in your workflows with using a file called schema.yaml. And this is where you could tell DBT, the pipeline, what are like the type of columns you expect, the names of the columns and the type that you expect, so that you can make sure that your desired format of the data table at the end and the source table are meeting those requirements. And it looks like it'll just run these free of charge once you configure them without a lot of fuss. That is pretty neat. I think that's a welcome feature of DBT. And as I mentioned, you can also, at the end of your analysis, literally have some additional SQL type of code to derive variables. Maybe you want to get the average and standard deviation after group processing. That will give you a new table in this. So each of these stages is going to generate different tables, and then you can kind of see then how it all fits together. But in the end, you've got a series of SQL files. Sometimes they have a YAML file to help with either the testing or the importing of it. And then with the DBT package, you have a run command, or I should say the run command is from UV to manage Python dependencies, but you have a command called dbt build, which will then go through the steps. It'll make its own DAG or direct acyclical graph to show the different steps and only rerun the tables that need refreshing based on what may be changed in the sources. So there is a way you can visualize the DAG as well, because DBT has a docs command that will bring up an interactive, or I should say a web-based page where you can look at all the steps, look at the different columns in your data sets, and also see what they call the lineage graph, which is the DAG. So again, for data engineering, this looks like a solid approach. And of course, you could feed those output tables that you get at the end into something like Streamlit, like he does in this example, to have a little dashboard that he used AI to create that dashboard. A minimal MVP does the job. So how does that look in targets? Now, again, in targets with CSVs, that's not going to be an issue at all, right? We can just import CSV and built-in base R. We could also do a whole, even with the read R package, you could do all sorts of things there. So with that, you just with targets, the main thing is you are writing functions to do each of the steps, such as, like I said, reading the files. You could have a read underscore files function that will help you with that side of it. You can also do, some munging with dplyr. Maybe you want to add, bind rows together, mutate. If you're familiar with the tidyverse, you can do anything like that in targets as you like. And then what's nice is you get to those intermediate steps. Again, nothing fancy here. It's simply writing functions to take what was maybe done in a step before, do some additional munging, return the object, and targets will keep record of all these objects in its cache as you're producing these. I'm only going briefly into this because I could talk for hours about targets, but the blog post has all these snippets. You can see all the steps in action, really straightforward. And then you get to really some of the nice goodies that targets gives you. The way to visualize the DAG, I think, is first class. I have not found a better framework for this. It's simply tar_viz_network, and you will see then the DAG in an interactive HTML graph powered by Viz Network, where you see the nodes that either have not run yet or have run, and they're colored differently. So you know what is already done and maybe what needs to be rerun if something in the sources change. So I would say if you're an R user and you don't have esoteric needs on the type of data you're looking at, targets, my hypothesis is targets is going to get you there most of the way. Now, John wraps up this post by looking at the different trade-offs and different intricacies of each of these. If you like SQL and you're doing data engineering as a whole, yeah, DBT looks really solid for you. It seems like you're going to be fitting right at home with this workflow. You don't necessarily have to do a lot. I wouldn't say you want to position this as folding in all of your analysis in it, but if you do a situation like he references, say, maybe a company of the scale of Netflix, will have different pipelines for the actual analysis of tables that it generates from its source data. But they may want something like DBT to do the data engineering side up to a point. Let something else take over on the analysis and visualization side. I could see that being very appropriate. With the type of analysis you're doing, though, and the type of data, if you're comfortable with R, I'm going to keep saying it, it's hard to beat targets in this case, for sure. I agree with John that I think visualizing the DAG is very efficient in targets. It just works. It gives you the information you need. And also, targets gives you such an easy way to inspect specific steps in your workflow. If you just want to inspect that manually and or regenerate just certain parts if you need to, or debug certain parts if you need to. Will Landau has done an immense job with all the infrastructure behind targets. There is so much you can take advantage of. So there are other solutions in this space across different languages. John mentions that there is Airflow that from the Apache organization that can help you both construct pipelines and schedule them. I know that's talked about quite a bit. On the R side of things, on more the data engineering side of things, where maybe targets isn't quite up to par with certain aspects, there was a package that we talked about probably last year called Maestro that is helping data pipelines on its own. So that if you were in a situation like Netflix, maybe Maestro might help with some of the data specific things, especially coming from data that's from upstream APIs or database connections that aren't as easily incorporated into targets based on the way it, tracks changes or caches, Maestro might be worth a look. I haven't played with it myself. I remember covering it last year, and it does show great promise. In the end, it's always what fits your workflow best. But I do love Jonathan's approach here. Take a practical problem of something where you know the steps you need to do that data processing and or analysis, and it may change over time, but the steps don't change over time. Maybe your data or your inputs change over time, but you don't necessarily have to rerun everything every single time. This is where targets and DBT will make you feel right at home. He does invite comments if there are any important trade-offs or use cases that maybe he hasn't mentioned here. Definitely don't hesitate to get in touch with Jonathan. He's on Mastodon. He's highly visible on that side of things. Always learning, always interacting with the community. So it's great to see another satisfied user of pipeline tools. And DBT and targets are great for these use cases. And I can't wait to hear what all of you do in your next pipeline adventures. And speaking of adventures, I know you can have many more adventures in the world of data science in your explorations of R. And that's where looking at the rest of the R Weekly issue will come to play. We have a great collection of additional resources across different categories, such as new packages, tutorials, and whatnot. So I'll take a little minute or two here to talk about some additional finds that caught my attention. Well, there is an innovative change on the horizon, or a massive update in the works, and that is actually the next major version of Quartal being called Quartal 2. Quartal 2 is going to be a significant rewrite of Quartal itself. Any guesses what language is going to be on the underpinnings? Yes, it is Rust. Everything's being written in Rust already these days, it seems like. But no, it's cool to see. But you may want to check out the issue, because Posit has a series of blog posts introducing some of the underpinnings and other innovative use cases of Quartal 2 that are happening. So Carlos has a great write-up here about how source maps and parsing is going to be handled with this new engine of processing Quartal documents. There's a lot to choose from here, especially if you're interested in tree sitter like things that we've been covering in past episodes. And they have one going for Markdown too. So I think this is going to lead to some interesting things. But yeah, Quartal 2, it's going to happen eventually. In fact, it may even be later this year. We'll find out. And we love to find out what great resources that you are finding out there. Or maybe you're creating a new package or a great new use case of R in the world of data science. We want you to tell us. The best way to tell us is to go to rweekly.org and send us a pull request to the upcoming issue draft, where you get a nice template in the upper right corner. Just click that little ribbon, and you'll be able to fill out a pre-populated template to tell us about your resource that you want to share. Could be blog post, could be a new package you've built, could be a community event that you want to get the word out on. We love to hear it all. So we're just a pull request away, as they say. And if you can write Markdown, you can definitely do a pull request. And with that, you can also get in touch with myself on the social media areas here. I am on various platforms such as Blue Sky, where I am at our podcast at bsky.social. I am also on Mastodon at our podcast at podcastindex.social. And I'm on LinkedIn. Search my name. You'll find me there. And in fact, we had a recent, you might say, accomplishment that's been brewing for a bit on behalf of the submissions working group. We now have officially on the R Consortium blog a write-up of the container and WebAssembly submission pilot that we did for a Shiny application to the FDA. Very, very interesting journey. I've talked about that in previous presentations, but it's a great write-up from the R Consortium blogging team. We'll put a link to that in the show notes as well. And with that, I'll close up shop here for episode 226. Who knows how it turned out in this new setup, but if it works well, it's going to make things a lot more fun for both Mike and I as we do this going forward. And yes, I will be back to using an open source stack if this does indeed pan out well. So, like I said, we'll close up here. Thank you so much for joining me for this episode of our weekly highlights. We'll try to be back to normal next week without just me blabbering on for 30 minutes or so. But I'm glad you listened anyway. And we'll be back with hopefully a new episode of our weekly highlights next week.